everyone, and welcome back to Knowing Nuclear. Today we're going to continue our series on isotopes for society, looking at paleoclimatology today. So as I mentioned previously, this is a technique where we can look at ice core data and using stable isotopes to look at the temperatures in the ancient history and compare them to the temperatures today. So what they do, they find a nice glacier, take a big drill all the way from the surface down to the bedrock underneath to capture the entire history of this area. They put it in the truck, bring it to the lab, where they can then examine the isotopic ratios and compare them over time. So a quick reminder, ice is made out of water, H2O, which contains oxygen, which is the one we're specifically interested in for this technique. We're looking at oxygen 18 isotope. It is stable. The normal oxygen is oxygen 16, by the way. So we know that the less oxygen 18 that is present in the water corresponds to a lower temperature at that time. So if we put this on the perspective of the ice core, if in this old section we have low amounts of oxygen 18, that corresponds to it being colder at that time. Then we can compare it to something a little bit newer. If we have higher oxygen 18, it's a higher temperature here. So we can use this technique to model the entire history of the ice core and then figure out how the temperature and the climate has changed over time. This technique has also allowed us to know more about ice ages and how they have happened and when. Also, really important, you can look at climate change in the past, compare it to how the climate is changing currently, and this is how we know that the current climate change is happening much more quickly than it has in the past, which is one of the reasons that it is of such major concern for us now.